7.6 problems. Number 15, they say to find these if the secant of theta is 3, which means the cosine of theta is 1/3. And so the cosine's positive, they say the sine's positive, so we're going to be in the first quadrant. And if I do cosine squared plus sine squared equals 1, that'd be 1/9. 1/3 squared is 1/9 plus sine squared equals 1. So the sine squared is 8/9. And if I take the square root of 8/9, I get the sine to be 2 square roots of 2 over 3 and positive. So the sine of 2 theta, the formula says that is 2 sine theta cosine theta. So we'd have 2 sine theta, 2 square roots of 2 over 3 times the cosine theta, which is 1/3. So we're going to get 4 square roots of 2 over 9. Cosine of 2 theta is cosine squared theta minus sine squared theta. So cosine squared theta is 1/9 minus sine squared, that would be 8/9, which is 7, negative 7/9. Sine of theta over 2, the half angle formula is this plus or minus 1 minus the cosine of theta over 2. And since we're in the first quadrant and half of an angle in the first quadrant is still in the first quadrant, so we're going to get a plus answer, not a minus on this particular one. So we're going to get the square root of 1 minus the cosine is 1/3 over 2. So 1 minus 1/3 is 2/3. Cut in half is 1/3. And cosine of theta over 2 is same thing here, plus or minus the square root, but just a plus in here, 1 plus cosine theta over 2. And since we're in the first quadrant, half of that angle is still in the first quadrant, so we're just going to get plus the square root of 1 plus 1/3 over 2. That's 3/3 plus 1/3 is 4/3, divided by 2 is 2/3, so that's the square root of 2/3. Now for problem 20. We're supposed to find the same things, but the cotangent is 3, which means the tangent is 1/3, and tangent's positive, and the cosine is negative. So if the cosine's negative and the tangent's positive, the sine must be negative, so we must be in the third quadrant. So in the third quadrant, and the tangent's 1/3, that's not a special angle, so if I go sine is 1 and the cosine is 3, that'll be out here someplace, 1 and 3. So the hypotenuse would be 9 plus 1, square root of 10. So to make it be in the unit circle, I'd have to divide by the square root of 10, square root of 10, square root of 10. So the cosine is negative 3 over the square root of 10, and the sine is negative 1 over the square root of 10. And so now I can do these. The sine of 2 theta would be 2 sine of cosine, so it's 2 sine of the angle times the cosine of the angle. So that's 6 over 10. Cosine 2 theta is cosine squared, so that would be 9/10 minus 1/10, which is 8/10. The sine of theta over 2 is, so if I'm in here, half of this angle would be, half of 180 is 90, so it's a little bit more, so it's going to be about there. So the answer for the sine is going to be positive because I'll be up here. So I'm going to use the positive one of these, so it's going to be the square root of 1 minus the cosine, minus a minus is plus, 3 over the square root of 10 over 2. And I won't worry about simplifying that. And the cosine of theta over 2, the cosine's negative, and if I move to half of it, it's still going to be negative, real small. And it's going to be the square root, and so it's going to be 1 minus a, just plus a minus, so it's going to be minus 3 over the square root of 10 over 2. Let's see, let's turn this so it's a little straighter here. Okay, so that's 20. Next one was 35 that was asked about. And it says h is the tangent, and it says find h of 2 theta. So they want the tangent of 2 theta formula. And on 35 they gave you a picture. One with a circle of radius the square root of 5. They said x squared plus y squared equals 5. And it's at A2, so the y is 2. 2 squared is 4. 4 from 5 is 1, so A must be the square root of 1, and back here, so it's minus 1. That's the point here. So the hypotenuse would be 1 squared plus 2 squared, which is 5, square root of 5. This is minus 1 and up 2. So now I can find the sine, cosine, and tangent of the angle. Tangents, 2 over the minus 1. And that was for thetas on this one. Theta's right there. So the tangent of 2 thetas, 2 tangent theta over 1 minus tangent squared theta. That's the formula that's in the book and that we derived in class. And so we would do 2 times the tangent, which is 2 over minus 1, minus 2, over 1 minus a minus 2 squared. So that's minus 4, negative 4 over 1 minus 4, which is negative 3, so 4/3. And that's positive. Well, if it's here and we double it, it's going to be over here someplace, and the tangent's positive. No, over here someplace. So, and the tangent's positive in that quadrant. So that's working out. That was number 35. Next one was 45. And 45 says, develop a formula for cosine of 3 theta. Well, if we're going to do that, we need to break this up, and we can call that cosine of 2 theta plus theta. That's 3 theta. And if we run that through the formula, that's going to be cosine of the first, cosine of the second, plus b minus sine of the first, sine of the second. And now cosine of 2 theta, we've talked about above here, is cosine squared theta minus sine squared theta times cosine theta minus this is 2 sine theta cosine theta is the sine of 2 theta times the sine of theta. So I've got cosine to the third theta minus sine squared theta cosine theta minus 2 sine squared theta cosine theta. So that would be cosine to the third theta minus 1, 2, 3 of these. 3 sine squared theta cosine theta. Now you could change the sine squared to 1 minus cosine squared and multiply that out and get a different formula, but that's one possibility for the formula. Now we're going to do number 50. 50 says, show that cotangent theta minus tangent theta over cotangent theta plus tangent theta is cosine of 2 theta. All right. So we got to establish this. Okay. All right. So the common denominator for these two, if I change these, this is going to be cosine theta over sine theta minus sine theta over cosine theta all over cosine theta over sine theta plus sine theta over cosine theta. So the common denominator is sine cosine. So I'm going to multiply the numerator by sine theta cosine theta and the denominator by sine theta cosine theta. To clear out the denominators, so this times this would cancel the sine and I'd get cosine squared theta. This times this, the cosines would cancel and I get minus sine squared theta. So all these denominators are gone. Now we go to the denominator. When we take this times this, the sines would cancel and I'd get cosine squared theta. Take this times this and the cosines would cancel and I get plus sine squared theta. This is 1 and this is cosine 2 theta. Okay, that was 50. The next one is 660. And it is cosecant squared of theta over 2. And we're supposed to show that comes out to be 2 over 1 plus 1 minus cosine theta. So cosecant is 1 over sine squared of theta over 2. And the sine is plus or minus the square root, the half angle formula, 1 minus cosine theta over 2, but we would have to square that. So that would get rid of the plus squared is plus and minus squared is plus, so we can forget those. The square root squared is gone, so we got 1 over 1 minus cosine theta over 2. So if I multiply the numerator and the denominator by 2 over, I'll just multiply by 2. These two cancel, and I get 2 over 1 minus cosine theta. Next one is 70. 70 says, oh, I'm not sure I want to do that one. I didn't mean to sign that, and I don't want to do that one. 71, we can solve this equation. Cosine 2 theta plus 6 sine squared theta equals 4. And we're supposed to find the answers between 0 and 2 pi. Okay, well, we got not 2 theta and 2 theta, so we're going to change this to cosine. This has got sine, so I'm going to change. There's another formula for cosine of 2 theta that says it's 1 minus 2 sine squared theta. That's pretty easy to derive. Plus 6 sine squared theta equals 4. So these would make 4 sine squared theta. And if I subtract 1 from both sides, I would get 3. And if I divide by 4, I got sine squared theta equals 3/4. And then if I take the square root, I get the sine of theta equals square root of 3 over 2 plus or minus. So that would happen. That's a special angle, so that's going to be pretty easy. Square root of 3 over 2 is when the sine's up here. At there, it's plus, and down here it's minus, so that's going to be pi over 3. Oops. And then here is 2 pi over 3, and here's 4 pi over 3, and here's 5 pi over 3. Those are the answers between 0 and 2 pi. That was 70, excuse me, that was 71, not 70. And then 75. 75 says sine of 2 theta plus sine of 4 theta equals 0. Well, I can use the double angle formula to cut this in half, so I'd have the sine of 2 theta plus 2 sine of half of this angle, cosine of half of that angle equals 0. I can factor out sine of 2 theta. 1 plus 2 cosine 2 theta. And if this is going to equal 0, then the sine of 2 theta has to equal 0. And if this equals 0, I subtract the 1, divide by 2, so the cosine of 2 theta would have to be minus 1/2. So when is the sine 0? At 0 and at 180, or 0 and pi, and 2 pi, and 3 pi, and 4 pi, and 5 pi. So 2 theta is going to be 0 plus multiples of pi, because they're both right across from each other. 0, pi, 2 pi, 3 pi, 4 pi. And so if I divide by 2, I get theta is 0 divided by 2 is still 0. plus multiples of pi over 2. And I'm supposed to find answers here between 0 and 2 pi, 0 less than or equal to theta less than 2 pi. So 0 would work. Pi over 2, which is pi over 2 more than 0. And another pi over 2 would be pi. Another pi over 2 would be 3 pi over 2. Another one would be 2 pi, but they didn't say include it. So then I have to go for the answers out of this one. And cosine is equal to negative 1/2. Negative 1/2 at 2 pi over 3, and also down here. So I'm going to write 2 theta. The angle will have to be either plus or minus 2 pi over 3 plus multiples of 2 pi. Divide by the 2 and I get plus or minus pi over 3. Divide that by 2. Divide this by 2 plus multiples of pi. So pi over 3 is between there and there. If I add pi to that, that'd be 3/3, so that'd be 4/3. Oh, excuse me, 4 pi over 3. If I add pi again, that'd be 7 pi over 3, which is bigger than 2 pi, so I can't do that. Negative pi over 3 is not between 0 and 2 pi, but if I add pi to that, I would get 2 pi over 3, and if I add pi to that, I get 5 pi over 3. Okay?